How to place down steel on the drawing. The next set of tutorials are going to show you the variety of ways you can place steel down on the drawing. You must choose the best technique based on the information that's given to you. Sometimes you're given 2 points to snap between. Sometimes you need to put in the elevation yourself. Sometimes you might just know the rise and run. So for each different scenario, there's a different way to draw your steel. We're going to go over each of them one at a time in the next sequence of exercises. How to draw steel with one elevation point. The easiest way to draw steel is with one elevation point, or keep it horizontal to the drawing. To do that, we're going to grab a steel wide flange shape out of the architectural bin. Here we're going to choose a beam from a preset catalog. We're going to choose the W18 by 86. We're going to hit place, and now PractiCAD is asking us to specify the start point of steel. You can see that in the command line. Before we specify the start point, we're going to go over to the item box. Notice here the steel tab is already depressed for us. We can choose our parameters, but we've already selected steel from a catalog, so the parameters are there for us. I currently have the slope at 0 and 0 because we're going to be drawing this flat, so we want both these numbers to be 0. And now what we're going to do is come over to the elevation box and just give it an elevation. In this tutorial, we're going to say we want the bottom at 10 foot. So I type in 10 foot and I hit enter. Now we're going to go back to our drawing space. PractiCAD is going to say to specify the start point of steel, we're going to click once to start. Now at this point it's going to be much easier to draw the beam if you've got your polar tracking set on. So currently I have polar tracking set on. Also what we're going to do is we're now going to hold the beam in a specific direction, and we can choose whether we want to give it a distance or we want to just eyeball the distance. In other words, if we click right now, this beam will be exactly this long. However, we can also hold the beam in a direction we want to go and then type in the value we want the length of the beam. For example, in this tutorial, we're going to type in 120 inches. You can actually see that being inputted in the command line. Currently, I'm typing in 120 and I'm going to hit enter. Once I do that, you can see that it's snapped so that this beam is actually 10 foot long. Now PractiCAD is saying to specify the rotation around the self-axes. Beams can be rotated along their center axes. If we've already got it at the rotation we need, we can just hold the cursor on the polar line and that'll keep it at 0. Or we could type in 0 and hit enter. And I'm going to type in 0 on the command line, hit enter. And now we've got a beam bottom at 10 foot. You'll also notice if we double click and go to the property box, you can see here that the length is 120 inches or 10 foot long. So that is how to draw a beam horizontal with one elevation point. How to place down steel between 2 columns. In this tutorial, we're going to show you 3 different ways to place steel between 2 columns and make sure you've got the proper elevation points. We're going to go into the architectural bin and we're going to grab a wide flange shape from a pre-existing catalog. We're going to click place. Then we're going to come over to the item box. Notice the steel tab is depressed, and we're going to say to hold this beam by the bottom center because we want to attach the bottom of this beam and lay it on top of the column. Then what we're going to do is we're going to click between both columns. Now notice currently that we have node highlighted. We're going to click on the center node of one column, and then we're going to click on the center node of another column. And then we're going to hit 0, enter for the rotation. Now notice that currently the elevation is at 0. It did not go to the top of the columns, which is where we wanted it. The reason is because columns have nodes at both the top and the bottom of the column. And AutoCAD is going to snap the entity you are holding to whichever node is closer to your current elevation. You can see that our current elevation was actually at 0. So AutoCAD actually snapped the bottom, or the point we were holding, the bottom center of the beam, to the node closest to 0. So if we wanted to make sure that the beam was going to be placed at the top of the column, and we wanted to make sure it snapped to the node on top, one of the things we can do is just set our current elevation higher than the top of the column. For example, we're going to come and grab that beam again. We're going to hit place, and this time we're going to take the red line, our current elevation, and set it to 100 feet in the air. We're going to hit enter. Now 100 foot is way above the top of our column. But once we go to snap to this node, the nearest node available would be the node at the top of the column. So it's just a little trick. We can now click here, and then we can come over here and we can click this as well, hit 0, enter for rotation, and now we have the beam perfectly placed at the right elevation. Another method for making sure we get the right elevation is to utilize the Replace Z option. Now there are separate tutorials on how to use the Replace Z, but here we're going to show you how to utilize an existing automatic and give it the proper elevation and make sure everything's correct. We're going to delete what we've drawn here, and we're going to go over to our automatic bin, and we're going to check the Z on button. That's going to be the AutoCAD or PractiCAD command automatic that turns Replace Z on. When Replace Z on is active, basically regardless of what elevation a node is at that you snap to, PractiCAD is going to place down that entity you're holding at whatever your current elevation is, which means whatever you put in the elevation box. So what we're going to do is we're just going to come and we're going to grab a wide flange shape. We're going to hit place, and we're going to put in exactly what elevation we want this beam to be. And that's going to be at 10 foot. So no matter what, wherever I place this on the drawing, no matter what node I snap to, regardless of where that node may be on the Z axis, when Replace Z is on, PractiCAD is going to follow the current elevation or whatever's in your red line in your elevation box. So what we're going to do here is you can see that it's at 10 foot current. So all we need to do now is just simply click here and just click here, hit 0, enter, and you can see that because Replace Z is on, we have the beam at the right height. One key thing to mention is if you do utilize this, once you're done using Replace Z, you probably want to make sure that you do shut it off. The last option is to control our endpoint snaps to make sure that PractiCAD puts the entity at the proper elevation. PractiCAD offers an endpoint snap which rides at the top, center, and bottom of the column. We're going to go into isometric view, and we're going to grab a beam, and we're going to attempt to place it, and we're going to isolate the endpoint. So I'm going to hold down the Shift key and right click, and we're going to go isolate the endpoint for this. And we're going to show you that currently PractiCAD is only highlighting one point, and you can see that that endpoint node happens to be, the endpoint snap happens to be at the center of the column. And the reason for that is inside the item box, underneath the column tab, we have a place here that says snap to, just like we do in steel. And you'll notice that currently it says snap to Z center. Now the snap to has to do with the endpoint node. And what that means is if we switch the snap to here to the bottom or to the top, that if we go to attach a beam and isolate the endpoint, that only that node will be available. So once again, if we come over, see here that the node that's now available for the endpoint is at the top of the column. No longer is it available in the middle. So we can utilize that to put it at the right elevation. So to demonstrate this, we're going to go back into the top view. We're going to grab a beam from our bin. We're going to hit place. We've already set the snap in the column tab here. It's already been set to snap to top. So you can see that here we've got the current elevation at 0. But even though the current elevation is at 0, because the only endpoint node available on this object will be the top one, it's going to snap it to the proper place anyway. So what we need to do is we're going to hold Shift and right click to isolate the endpoint. And it's important to make sure we isolate endpoint. And we can get a verification by just holding our mouse here. And you can see that AutoCAD's showing us that we're holding the endpoint. We're going to click once. Then we need to Shift right click again and isolate the endpoint for this connection. We hold it here. Once we see endpoint, we can click. Now after we rotate it, you'll notice that once again we are at bottom 10 foot where we want it. So that concludes the 3 different methods to making sure we get the right elevation points when connecting between 2 columns or any 2 entities in AutoCAD. How to place down steel using 2 elevation points. In this tutorial, we're going to show you how to place down slope steel using lines that are both at 0 feet to the drawing. In other words, an engineer has given us a background drawing. The background drawing is at 0. We've got two lines representing steel, and we would like to attach a beam between them in the BIM model, but at a slope. Considering that both lines are at 0, we're going to have to use our dx, dy, and dz commands to offset the beam at the proper elevation. We're going to go into the architectural bin. We're going to grab a wide flange shape and click place out of our catalog. We're going to come over to our elevation box and notice right here under dx, dy, and dz, all values are set to 0. That essentially means that our cursor is currently directly on the steel, and it's holding that steel by the bottom center in this tutorial. What we'd like to do is place one side of the steel at 5 foot above this line and the other side of the steel at 10 foot above this line. By using two DZ offsets, we can accomplish this. So what we're going to do is we're first going to go into the elevation box and we're going to put in DZ 60 inches. If you are using your format and precision in feet and inches, you could also type in 5 foot right here, and that will do the same thing. We're going to put in 5 foot, and then we're going to click on this line. Notice I've got the nearest snap lit. I'm going to click once. What AutoCAD has done is it has actually taken this beam and it has snapped it to a point 5 feet above that line because of the DZ command we have. Now what we're going to do is change the DZ, and we're going to change it to 10 foot. And then we're going to go back over to the second line. And we're going to hold it here. I'm using the perpendicular snap to make sure that everything's level. And I'm going to click again, and then we're going to click for rotation. Notice that now we've got the beam bottom at 5 foot to start and the other bottom at 10 foot, even though both lines are flat. This makes it very easy to draw slope steel between points, even if those points aren't at the right elevation. Of course, if you're working in a BIM or 3D model and you're snapping between 2 points that are actually at their actual elevation, you will not need to use offsets. However, if you are working with a background, using the DX, DY, and DZ keys can make it easy to get the proper elevation between 2 points. One thing you must remember to do, though, is once you've used the elevation offsets here and you're no longer using them, make sure you hit the 0 or reset key, which will bring all the values back to 0. If you don't do that, your crosshairs are going to be off whatever values you have in here when placing down duct and other objects. How to draw steel using your Auto Steel tool. PractiCAD offers a tool that allows us to quickly take flat, two-dimensional steel drawings that are given to us by an engineer or architect and convert them into 3D PractiCAD drawings with the proper elevations. To do this, we must utilize our Auto Steel tool. In this tutorial, we have 2 lines that are on the drawing, and these are standard AutoCAD lines. What we're going to do first is convert these basic AutoCAD lines into intelligent PractiCAD lines. You will notice here that if we click on the line, you can see that it's got all the standard properties of an AutoCAD line listed here. Under geometry, we've got the start XYZ and all the following parameters. What we're going to do is convert these lines to PractiCAD layout lines. To do that, we must go into the Create from Lines icon. This is located on your PractiCAD ribbon or Express toolbars. I'm going to click on it once. When we do that, PractiCAD is going to ask us in the command line to select objects. Select both objects and then hit enter. When we do that, you're going to know that we've converted the lines because PractiCAD will usually change the line's color because it moves it to a different layer. Now if you click on the line, you'll see that it's under the PractiCAD layout line segment, and you can see that we've added geometry parameter airflow. We also have intelligent stretch nodes that have been added to this line too. Layout lines can be converted to duct, steel, or pipe. In this tutorial, we're converting them to steel. Once we've got the layout lines converted, now we need to change them into steel. To do this, we're going to go over to the Auto Steel button in our PractiCAD ribbon. We're going to click on it. Inside here, the first thing we must do is on the left-hand side, select the beam type we'd like to use. Everything will be listed here from all of your wide flange shapes to your H-piles all the way down to bar joists, which can also be utilized for conversion. In this tutorial, we're going to open up wide flange shapes and we're going to pick a W36 by 194. Now we have to choose all of the rest of the parameters on the right. The first choice should always be set to top. Normal top means that if we're in plan view, the top of the beam should be looking directly at us. If we were to switch this to front view, it means the top of the beam would be looking directly at us if we were looking at the drawing from front view. And the same with bottom, left, and right. 99% of the time, we always leave normal set as top. And the way this auto steel button works is whatever settings you have here, the second time you open it, the settings will be saved. So this is usually set to top, and it's very rare that I would ever change it. Next, we have rotation angle. In other tutorials, we show you how to rotate steel. We can have these beams come out, converted, and rotated if you'd like. Most of the time, the rotation angle I have selected is at 0. Now we've got the hole parameters. We can take this line and use it to keep the steel lined up with the top, center, or bottom. In this tutorial, we're going to say that we want the bottom of this steel to be at 10 foot. So we're going to say hold the steel by the bottom. Now we have to choose our start point and end point elevation types. Notice that we have two choices, absolute and by layout for start elevation, and we have the exact same choices for end elevation because we can convert layout lines to sloped steel. Absolute means that whatever value we put in here, that PractiCAD is going to put that beam at that absolute elevation. In other tutorials, we explain the concept of relative marks and relative bottom. When we are using the auto steel tool, we must always put the absolute elevation of the beam from 0, not from relative. The way it works is from 0. If we choose absolute, we can now give it a start point elevation value. For example, here we're going to say 120 inches or 10 foot is going to be the start point of this particular beam. If we wanted to just convert it to the elevation of the actual layout line, we could select by layout and then offset it from a layout line or just convert it where the layout line is. Most of the time we're doing it from the absolute elevation. So we're going to say start point elevation 120. We're going to set the endpoint elevation also to absolute 120. This means that the beam will be at 10 foot bottom and it'll be flat when we convert it from the lines we've already changed. The last option is to remove layouts. If this button is checked, PractiCAD will delete the layout lines after it converts the steel. If it's unchecked, it will leave them. And in the tutorial, we'll go over both scenarios. So what we've got here is to hold the steel by the bottom. Start point is going to be the absolute 10 foot in the air. End point is going to be absolute 10 foot in the air. And we're now going to press OK. At this point, it says to please select entities. And we can select as many entities as we want, and PractiCAD will convert them all at the same time. We're going to start by just clicking on this one line and then hitting enter. When we do that, PractiCAD has converted that line into a W36 by 194. The bottom is at 10 foot. To do this again to represent a slope, we're going to go back into Auto Steel. Notice that the settings are exactly where we left them. It always picks up the last settings used. We're now going to say endpoint elevation is going to be 240, so 20 foot. And we're going to say remove layouts, which will remove the layout line when we're done. We're now going to press OK. We're going to click on this line and hit enter. When we do that, you can see that PractiCAD has placed a W36 by 194. And here we have the bottom at 10 foot on one end and the bottom at 20 foot on another end. That is how to utilize your auto steel button.